The video for today is section 1.3, special trig limits. Your homework in section 1.3 is 67 through 82. Again, what we did 2 days ago is we found limits by using properties, which allowed us to use direct substitution. And then yesterday, we found out that sometimes we cannot find the limit through direct substitution, and so we learned 3 special algebraic properties or techniques that allowed us to be able to find the limit. Now these are going to be your special trig limits. For an example, let's find out a problem. Why do we need these special trig limits? How do you evaluate the limit of sine of x over x as x approaches 0? By direct substitution, and sine of 0 is 0. It's indeterminate. Again, on this one here, direct substitution. And so cosine of 0 is 1, but 1 minus 1 is 0, indeterminate. So let's go get our special trig properties. Our special trig properties for limits are the limit of sine of x over x as x approaches 0, no other value than 0, then it's equal to 1. The limit of 1 minus cosine of x over x as x approaches 0 is 0. And both of these can be discovered graphically. You can graphically find the limit being 1 and 0. And I will show that to you tomorrow in class. So let's do some examples using these special trig properties. So the first one is a limit of tangent of x over x as x approaches 0. So again, just by direct substitution, if I put in 0, I cannot find that limit. So then I have to rewrite this in the form of these 2 special trig properties. So I think what I'm going to do is I'm going to go ahead and take tangent and change it into sine of x over cosine of x over x. Then I'm going to go ahead and multiply by the reciprocal. Right, x over 1 times 1 over x. So let's put the x here. So if you notice, this is approaching 0. There's sine of x over x. I just also have a time cosine of x. So let's just separate it into 2 limits. Let's take out the sine of x over x as x approaches 0 times the limit of 1 over the cosine of x as x approaches 0. Then I double check my math. If I multiply this and this, do I get this back? And I sure do. So the limit of this is 1. This one here I do by direct substitution because it is not one of those 2 special properties. Cosine of 0 is 1, so therefore your limit is 1. Next example. The limit of sine of 7x over x. If I put 0 in the denominator, you can see it already fails. Well, let's go back and let's take a look at this property. The biggest thing is that it's not x. The biggest thing is that these 2 items match here. Whatever this angle is what has to be divided out in the denominator. So since this is 7x, in order for me to use this property, I need to have a 7 down here. So let's multiply by a special one, 7 over 7. So let's rewrite it. So I want sine of 7x. In fact, I'll put the 7 in front. 7 times sine of 7x over 7x. There it is. So let's break it up again. The limit of 7 as x approaches 0 times the limit of sine of 7x over 7x as x approaches 0. Here is that property. Whatever this angle is what you're dividing out. So as it's approaching 0, this is equal to 1. This is the constant 7. So my limit is 7. Let's do a couple more examples. The limit of sine of x over 7x as x approaches 0. So I put 0 in the denominator. It fails. I cannot find this limit. So therefore, I have to use that special trig property in which I need this to match and this to match. Well, I can't shove something else inside of that angle measurement, so therefore, I need to factor out that 7. So let's separate it out. The limit of 1/7 times the limit of sine of x over x as x approaches 0. Again, double check your math. 1/7 times this will get me this. The limit of this is 1/7. The limit of this by the special property is 1. So my limit is 1/7. Next, the limit of cosine of x times sine of x over x as x approaches 0. One more time, I'm not going to be able to find the limit as I put x in the 0 into the denominator. But I do see my special property here, so let's just separate it right now. When I multiply this function and this function, I get back the original function. So therefore, I can go ahead and take the limit of each part. This is by direct substitution. This is by that special property, it's 1. Cosine of 0 is 1. 1 times 1 is 1. Next example. The limit of tangent squared of x over x as x approaches 0. If you remember, we just got doing a problem. In fact, our first example was tangent of x over x, and that equaled 1. So watch what I can do with this. The limit of tangent of x as x approaches 0 times the limit as x approaches 0, tangent of x over x. I multiply this back together, I get this. We already know from the very first example that that limit is 1 by direct substitution. Tangent of 0, well, that's sine of 0 over cosine of 0 times that 1. And so sine of 0 is 0, cosine of 0 is 1. That's 0 times 1. That limit is 0. I have two more examples. The limit of sine of x times the quantity of 1 minus cosine of x over 5x squared as x approaches 0. Well, this looks like that other identity. It's 1 minus cosine of x. I need it over x, and I need it approaching 0. So I've got everything there. Let's break it apart. So I want this left alone, so let's take out the sine of x out of the numerator, and I want a 5x. Because what is left is 1 minus cosine of x and the x in the denominator. So if you multiply this and this, you'll get this back. So this almost looks like a special property, because right now I can't take the limit of this. So that's the limit as x approaches 0 of 1/5 times the limit of sine of x over x as x approaches 0 times the limit of 1 minus cosine of x over x as x approaches 0. The limit of this is 1/5 times the limit of this is 1. The limit of this by the special property is 0. 0 times anything is 0. Last but not least, one more example. The limit of sine of 7x over 5x as x approaches 0. Well, I cannot divide out that 7. It's in the angle measurement. Sure, I can take out the 5, but the 7 has to stay. Therefore, I know I must have a 7 down here with the x. So let's force a 7 in the denominator by multiplying by a special 1. So let's put 7 times in front, sine of 7x. And then I want the 5 here and the 7x here. So 7 times sine of 7x is right here. 5 times 7 times x is all right here. This limit is 7/5. This limit is 1. This limit then is 7/5. Thank you.